In this video, we're going to take a look at how we can do what's called rationalizing denominators. Sometimes a fraction, it might break a certain rule, and I'll tell you about that rule in a minute. And so what you have to do is you have to do an operation called rationalizing the denominator so that that fraction no longer breaks this rule. So the rule I'm talking about, we'll write it over here in the notes section. The rule that I'm talking about here says that the denominator of a fraction, remember denominator is the bottom number, the denominator of a fraction may not contain any irrational numbers. So that's the rule that we have to kind of watch out for breaking. We're not allowed to break this rule that says that the denominator of a fraction may not contain an irrational number. And sometimes we end up with an expression that breaks that rule. So for instance, if I look at number 1 right here, it says the square root of 15 over 2. Now, in one of the previous videos, we learned that if I have the square root of a divided by b, I can look at that as the square root of a divided by the square root of b. And that's exactly what the square root of 15 over 2 means. It's the square root of 15 divided by 2. So we can look at that as the square root of 15 divided by or over the square root of 2. So let me write that. The square root of 15 over the square root of 2. But you see, that breaks this rule that says that the denominator of the fraction cannot contain an irrational number. So what we're going to do is it's called rationalizing the denominator, and we're going to multiply this fraction times a special version of 1. And we're allowed to do this because when you multiply by 1, you're not changing the value of a number, right? 1 is considered the multiplicative identity, which means that if I multiply something by 1, its value doesn't change. And then the version of 1 that we're going to use looks like this. It's going to be the square root of 2 over the square root of 2. Now this number here is a 1 because it's a fraction with the same value in the numerator and the denominator, and we know that all of those fractions where it's the same thing on the top and the bottom, they're equal to 1. So I'm going to multiply this by this special version of 1. And you'll see what's going to happen is it's going to get rid of this problematic square root of 2 on the bottom. That's an irrational number. It's going to get rid of it. Let me show you how. The numerator of this is going to turn into the square root of 15 times 2. We're going to take these two individual numbers that are each under their own square root, and we're going to combine them under one bigger square root. So that's going to be a 15 times 2. We're going to do the same thing to the bottom technically. So that's going to be the square root of 2 times 2. Okay, so now I'm going to come down here to this kind of lower portion of this box, and I'm going to clean this up. This now looks like the square root of 30 over the square root of 4. I just multiplied the 15 times 2, and I multiplied the 2 times 2. But the square root of 4 is just a 2, right? Since 4 is a perfect square, we know that its square root comes out as a whole number. In this case, it comes out as 2. And in the numerator, we still have the square root of 30. You see, what happened there is I multiplied this original fraction times this special value of 1. And I chose that value of 1 as the square root of 2 over the square root of 2 because I knew that when I take the square root of 2 and I multiply it times itself, I'm essentially doing two things that are going to cancel each other out to this 2, right? The 2 is getting square rooted, but it's also getting squared. And those two things are going to cancel each other out. So when I do the square root of 2 times the square root of 2, I'm just going to get 2. It might be worth kind of writing over here off to the side in your notes section that if I do the square root of a number times the square root of that same number, I'm always just going to get whatever that number is. So square root 2 times square root 2 gives me 2. Square root 4 times, well, I guess that's a bad example. Maybe square root 5 times square root 5 would just give me 5. The square root of number times the square root of a number will just give me that number. And now I would maybe think about, can I simplify this numerator? The denominator is now fine. Like it looks fine. It's not breaking our rule anymore. It's just a 2. And the numerator, I would think about, can I simplify it? In this case, I cannot, because 30 does not have any perfect square factors. It's not divisible by 4, 9, 16, 25, and then we're up past 30 already, so we know it's not going to be divisible by anything more than that. So this is just going to be my answer, the square root 30 divided by 2. And remember, I can always check to see if this works. I can type in the square root of 15 divided by 2, or I can maybe type in square root of 7.5 if I just know that 15 divided by 2 is 7.5. Square root of 7.5, I can type in the square root of 30 divided by 2, and I should get the same thing both times. And that's how I can kind of check to see if I did this correctly. Let's do a few more examples like this where maybe some different things are going to happen. You can see in number 2 we have the square root of 8 over 3. And so we're going to think of that as the square root of 8 divided by the square root of 3. But now we need to clean up that denominator. So we're going to multiply top and bottom by the square root of 3. We're going to multiply by 1. It's just that 1. It's going to look like the square root of 3 over the square root of 3. Now my numerator is now going to be the square root of 24. I just kind of skipped a step where I just mentally went ahead and multiplied the 8 times the 3 and put it under a square root. So that's a square root of 24. And I know my denominator is now going to be just 3, using this rule here, that the square root of 3 times the square root of 3 is just going to give me 3. But what I need to do now is I need to simplify that numerator, right? So I'm going to come back over here. I'm going to write this again, square root 24 over 3. And I'm going to think, all right, 24, I know that is divisible by 4. It's 4 times 6. And that square root 4 is now going to turn into a 2. And I'll have a 6 that's still left under the square root. So here is my final simplified version of the square root of 8 over 3. It's 2 root 6 over 3. I know this might not look a lot simpler than this, but we have to remember that this is technically breaking a rule because it's taking the square root of a number so that I'm going to end up with an irrational number in the bottom of this fraction, and I'm not allowed to do that. So that's why I got to make it look like this, so that the denominator looks all good. It's just a whole number in the denominator. Let's look at the next one. It's the square root of 30 over 8. Now what I can do with this one is I can look at this fraction and say, wait a minute, before I start with all of this stuff, what if I simplified that fraction? I can tell that I can divide both the top and the bottom of that fraction by maybe 2, right? And that's going to give me now the square root of 15 over 4. And then I can look at that as the square root of 15 over the square root of 4. And now that square root of 4 is just going to be a 2. So I have the square root of 15 over 2. And I'm done because my denominator now looks fine. It's just a whole number in the denominator. So I don't have to worry about rationalizing it. I could have done this one another way. I can just kind of show you here the second way I could have done that problem. I could have looked at it as square root 30 over square root 8. And I could have multiplied by the top and the bottom by the square root of 8. And that would have been the square root of 240 over 8. And then that square root 240, now I got to start thinking about, oh gosh, what perfect square factors go into 240. And I would have gotten that it's actually 16 times 15. So that's the square root of 16 times 15. And that's going to be over 8. And now I would have 4 root 15 over 8. And now this 4 and this 8 will cancel and turn that 8 into a 2. And I would have square root 15 over 2. But you can see, if I just reduce that fraction way back at the beginning, it's a lot simpler problem than doing it this way. And so that's why I think that's a good idea, to try and reduce that fraction back at the beginning. Now in this last example, I have 2 times the square root of 12 over 30. So let's see if we can apply all the things that we've learned so far and do this one. I'm going to simplify that fraction by dividing the top and the bottom by, let's see, I can divide the top and the bottom in this case by 6, right? If I divide that by 6 and I divide this by 6, I'm going to have 2 over 5. So now this looks like 2 times the square root of 2/5, which is going to be 2 times the square root of 2 over the square root of 5. But instead I'm going to write that as 2 root 2 over the square root of 5, because this is really like 2 over 1 times the square root of 2 over the square root of 5. And so if I just multiply those fractions together by multiplying numerators and then multiplying denominators, then what I end up with is 2 times the square root of 2 and 1 times square root of 5. So top is 2 root 2 and bottom is square root 5. But now I need to clean up that square root 5 on the bottom. So I'm going to multiply the top and the bottom of this by the square root of 5. And that's going to give me 2 times the square root of 10 over 5. And that's my simplified answer, 2 root 10 over 5. The denominator isn't a problem anymore. It's not a square root. What I do have under the square root is the number 10, but the number 10 does not have any perfect square factors, so I don't need to clean that up at all. So I just have 2 root 10 over 5.